A Hiker's 2 valve radio receiver. Now this set was sent to me by a fellow enthusiast from New Zealand, Lance Neem, who has done a video on the set, but he sent it over to me to have a look at, and yeah, it's been quite an interesting exercise. But before we have a look at the details of the set, I'll just run through the medium wave band. I've had problems getting the set to actually oscillate, but I've sorted that for the medium wave band at least, and yeah, we'll just have a run through.
For the people of Massachusetts,
Now, as you can hear, it's not very loud, but 19 volt or 18 volts high tension.
Of applause when the camera would pan over Congress.
The regeneration's very critical. The potentiometer value's way too high.
In his opposition to this development, they've also been in touch with the Regional Land Council. They say they won't be commenting publicly at the moment because it's an active application. But Michael Regan is with us now. Afternoon to you, Michael. Full-time has been having to do overtime, working 7 days a week or really long hours. That doesn't sound sustainable if you can't find full-time nurses.
This station here, it's 2LT, which is about 60 k's distance, 5 kilowatts, but it's a directional station aimed away from where I am. But it's a good test for daytime sensitivity, if I can just get the regeneration at the right point. There's a lot of backlash.
The inside leaves bars. Wandari Delighty showing us silver. The bag 4x4 seat covers the perfect protection, comfort and style for your four-wheel drive interior. Safe from spills, mud and everyday mess.
Looking at the front panel of the set, we've got the main tuning control here, vernier tuning control there, aerial, earth, headphones, and this switch enables the speaker as well as the headphones. It's the on-off switch, the regeneration, and we have this band switching arrangement which uses two switches, and the reason for that is because when this set was built it seems that there was no six-way switch, so the guy who built it has a three-way switch and a two-way switch to get the 6 positions. At the back of the set, you can see it's got 6 coils, which is a bit of overkill for something which runs up to only 9.6 megacycles. 2 valves. It would appear that the set was based on the Hiker's circuit, and these were originally type 49 valves, but the constructor has made up adapters to use a 1Q5 and a 3Q5 instead, which, I mean, given a choice, they're actually better performers. There's a audio interstage transformer, because one of these is the detector valve and then the other is the audio output valve. You can see the complexity of the switch wiring, and from an RF point of view it's not very good, because you've got all these long unshielded wires running all the way back to these coils here, and yeah, a lot of stray coupling and everything, and it's, yeah, not very good. Regeneration control. As usual, a 500k pot has been used when it only really needs to be about 2.5 or 5k at the max, and that makes it very critical to adjust, lots of backlash. So that's not a good aspect of design. Okay, underneath the set we have got main tuning condenser, about 400 picofarads, the vernier tuning condenser. I haven't actually measured it, but I would say it's probably around 30 picofarads. Grid leak resistor and grid leak capacitor for the detector. So this socket is for the detector and that one's the audio. Then we have all these 4-pin sockets for the coils. The speaker has a transformer mounted on it. I've been using a couple of parallel D cells for the heater supply. The set originally used a number 6 dry cell, also 1.5 volts, and for the high tension I'm just using my bench power supply set to 18 volts. So okay, we will have a look at the circuit diagram next. We'll have a look at the circuit now. I've described it in somewhat greater detail in the website article, which I have linked in the description, and I've also provided a link to Lance Neam's original video on the receiver. So having a look at the circuit, it's actually quite conventional. So we've got the 6 coils. Now the frequency coverage is 560 kilocycles up to 9.6 megacycles, and that's actually not much of a coverage for 6 coils. It should be possible to go from 560 kc up to 30 megacycles with 3 coils if the set's properly designed. But I think the restricted coverage is largely because of the method of aerial coupling. Instead of primary windings on each of the coils, the aerial is connected straight to the grid coils via a low value capacitor. The problem with that method is that you're loading the coil with the capacitance of the aerial in series with that capacitor, and this capacitor here is 50 picofarads, which is actually quite high. So there's a lot of aerial loading, and that causes difficulty with regeneration. You get dead spots, you restrict the tuning coverage, and the whole thing is dependent on the particular aerial that you're using at the time. So it's a very poor way of doing things, but people like doing it. I don't know if it's because they can't be bothered winding primary coils, I don't know, but I don't like it, and but we're stuck with it here. So the coils are switched by this rather complicated arrangement, as you can see, and that's because the constructor had used a 3 position rotary switch instead of a 6 position, and to do that required also using a two-way switch as well. So basically the coils are switched in groups of 3, and then in turn either of the groups of 3 is switched by the two-way switch here, and it's the same with the feedback windings as with the grid coils. So getting closer to the input circuit of the detector valve, we've got the normal tuning condensers, the vernier and the main one, the standard grid leak components, 2 meg resistor and 250 picofarad grid condenser. I talked about how the grid leak detection works in the video I did on the 1Q5 receiver, which I'll also link in the description. The circuit's otherwise, quite conventional. The regeneration operates with this potentiometer here wired as a rheostat, and that shunts the amount of RF which can appear across the feedback windings. So basically, the lower the resistance of this, the less RF voltage appears across the feedback winding, the less feedback there is, the less gain. And as with every regenerative receiver, the maximum point of sensitivity is just before it goes into oscillation. And as I've pointed out before, this value of potentiometer is way too high. It should be no more than about 5k, maybe 10k to get it to oscillate on the shortwave bands, but 500k is just too critical. There's a lot of backlash, as you saw when I was tuning through the medium wave band. It makes it a difficult receiver to use. The audio from the plate passes through this audio transformer. Now it's a 5:1 or 1:5 interstage transformer, and the way it's connected is so that there's an increase in gain. In theory, the voltage here is 5 times what it is here, but in practice it's a bit less than that. The output valve is wired conventionally and feeds a loudspeaker through a transformer. There's also a headphone socket, and that's got normally close contacts in it, so that when you insert the phone plug it disconnects the speaker. But our constructor thought that he would like to operate both at the same time, and hence we have the bypass switch there. Now the 1Q5 and 3Q5, I've talked about them before in the other video. These are battery audio output valves, normally running at a high tension of 90 volts and heater voltage of 1.4, or in the case of the 3Q5 it can run at 2.8. Now electrically the two valves are the same except for the heaters. So the 3Q5's got the centre tapped 2.8 volt heater, so it can run at either 1.4 as it does here with the sections in parallel, or in series at 2.8 volts, and the 1Q5 just has the single 1.4 volt heater. The heater voltage is 1.5 volts as I mentioned before, and it's the positive terminal is connected to earth, and that means that the 3Q5 output valve is getting minus 1.5 volts bias. The only other curious thing about this set is the high tension voltage. It would appear that it's probably designed for about 18 volts. The 1Q5 circuit, you don't want to operate with anything more than that because it's running without any bias and it's got a transformer load, so there's nothing really to limit the plate current except for the natural current flow in the valve which is going to be high with no bias, and the DC resistance of the primary winding. So about 9 to 18 volts is right for that. And also with only minus 1.5 for the output valve, you don't want to be running at sort of 45 or 90 volts. And the other thing, of course, is that the set was apparently designed to operate with 49 valves in space charge mode. So that means definitely no more than about 18 volts. And the way the circuit is with the 1Q5 and 3Q5, the valves are wired as conventional tetrodes. That is, the signal comes into grid 1, the screen grid is connected to the high tension. That's the case with the 3Q5 as well. When the valves are 49s on low high tension, the operation of the grids are actually reversed, so the signal would be fed into what would otherwise be the screen grid, and what is normally the control grid is connected to the high tension or a intermediate positive voltage. Now, an interesting discovery with this set is that although it appears to have been designed to take 49s, the constructor has actually got the grids the wrong way round, and the 49 is actually connected like this. And surprisingly, they do actually work. Not as well as the 1Q5, but I mean the set would regenerate and sounds came out of it. So I think, yeah, there's a lot of things about this set which are not quite right. And we'll have a look at the just the construction of the chassis. As you can see, the whole chassis been soldered together. There's no nuts and bolts, and unfortunately it has made the whole thing rather flimsy as it's come apart in the post. The problem being, and I could see it here, that it hasn't been fluxed and the solder has not flowed under the metal, so it's just joined by the solder at the seams but not actually underneath it. So yeah, it looked nice to start with, but yeah, it needs to be rebuilt with nuts and bolts. Yeah, the solder's just not up to it. But aside from that, I mean, it's, you know, quite an attractive set, and you know, the guy who built it went to a lot of effort. But yeah, just pity that yeah, the electrical design of it and the layout could have been substantially improved on. And one of the things when you got lots of coils like this is that they can interact with each other even though they're not actually switched in the circuit. And during the testing of each of the bands, I did discover that. So I mean, the coils need to be, you know, mounted at right angles to each other, or short-circuited, or the ones which are not in use short-circuited, and so on. I don't know how you'd get around the excessive lead length of the rotary switch and all these RF wires. I think to have the coils mounted at the back of the switch might be a better thing, but also, I mean, if I was to rebuild this, I would have less coils in it. which would simplify things. So there you have it, a hiker's 2.